Welcome to the deep dive. It feels like almost every company these days is grappling with just a huge number of APIs.
Oh, absolutely. It's getting really complex.
Yeah, you've got your MuleSoft ones and all the non-MuleSoft ones, and they're deployed, well, everywhere, cloud, on-prem. It can be a real headache to manage.
It's a challenge we see popping up constantly, as businesses bring in more tech, different ways of deploying the sheer number and the variety of APIs, it can really slow down efficient management.
Exactly. And that's kind of where this idea of universal API management comes in. It's about trying to, well, bring all those scattered APIs together under one management umbrella.
Right, using the Anypoint platform.
Precisely. So you can manage them, secure them, govern them, all from that one place, no matter where they came from or where they're running. It means you don't need like 5 different tools and skill sets.
Which can save a lot on costs
Mm.
and just make life easier for the ops teams, right?
Totally. And a really key piece of making this universal API management actually work is something called Anypoint Flex Gateway.
It's specifically designed for this kind of mixed API landscape.
So that's our focus for this deep dive, Anypoint Flex Gateway. We really want to get under the hood, understand what it is, how you actually set it up and use it.
And what the real benefits are when you're trying to tame that API sprawl.
Yeah. We'll kick off with the basics. What is Flex Gateway? What's its purpose? Then we'll break down its architecture a bit.
The control plane and the runtime. Kind of like the management office and the factory floor, maybe.
Yeah, good analogy.
Yeah.
Then we'll look at connected versus local modes. What's the difference there? And the main deployment patterns. Standalone, ingress, egress, sidecar.
And after covering the concepts, we'll dive into the specifics of Vicas's demo, how he set it up as a Linux service, used multiple replicas, and even brought in Redis for shared rate limiting.
And finally, we'll wrap up by looking at the pros and cons. What are the benefits, and are there any limitations to be aware of?
Sounds like a plan. The goal here is really to give you a solid, practical understanding of this tool.
Okay, let's jump in. What is Anypoint Flex Gateway, fundamentally?
Okay, so at its core, Anypoint Flex Gateway is designed to be an ultra-fast, very lightweight API gateway. It's actually built using Envoy technology under the hood.
Envoy, right. Heard of that.
Yeah, it's pretty popular.
Yeah.
And Flex Gateway's main job is to manage and secure your APIs, really wherever they happen to be running. Think of it like a flexible security guard for all your different APIs.
Ultra fast and lightweight, that sounds crucial, especially with the kind of traffic demands we see today.
It really is. It's built for performance, so it can handle demanding applications, microservices, but it still provides that enterprise-level security and manageability you need.
And how does it fit into the way people build software now?
Well, another key thing is how smoothly it integrates with DevOps practices and CI/CD pipelines. Yeah.
So it fits into that automated workflow.
Exactly. It allows for more automated, efficient API management, which is what everyone's aiming for.
Makes sense. Now, you mentioned 2 main architectural components earlier, the control plane and the runtime. Can you unpack those a bit more?
Sure. So the control plane, that's the part hosted by MuleSoft within the Anypoint platform. It's like your central command center for management and visibility.
Okay, so where you do the configuration.
Pretty much. This is where you go to, build your API definitions, apply security policies, deploy those APIs out to the runtime. You also use API Manager for monitoring and Runtime Manager for configuring the runtime itself, all centralized.
Right. And this connection to the platform, that's key for the control aspect.
Absolutely. That secure connection is what lets you manage everything centrally, push out policies, see what's going on.
Got it. So the control plane gives the orders. What about the runtime? That sounds like where the action happens.
That's exactly right. The runtime is the gateway instance itself. It receives the commands and configurations from the control plane, and then it does the actual work routing traffic to your backend APIs,
Right.
enforcing the security policies you defined.
And how does it talk back to the control plane? Securely, I hope.
Oh, definitely. The communication between the runtime and control plane is secured using MTLS, that's mutual TLS, where both sides authenticate each other, and standard HTTPS. So, yeah, security is built in there.
Good. What about handling lots of APIs or heavy traffic? How does it scale?
Yeah, good question. A single Flex Gateway runtime or replica can handle roughly up to 1,000 backend APIs based on the docs. But for real-world scenarios, especially for high availability and better performance.
You run more than one.
Exactly. MuleSoft recommends deploying multiple gateways in parallel. If you're doing the self-managed deployment, these parallel instances are called replicas. Adding more replicas just boosts your capacity and makes the whole setup more resilient.
Scales horizontally. Makes sense. And what types of APIs can it actually manage? Is it just for REST?
It's primarily designed for managing HTTP and REST API instances. Now, it doesn't have native support for, say, older SEP protocols or things like XML schema validation directly.
Ah, okay, so no SEP.
Well, not natively, but you can still use an HTTP API instance within Flex Gateway to secure any API that communicates over HTTP. So even if you have backend SIP services, as long as they expose an HTTP endpoint, Flex Gateway can sit in front and manage access to them.
Interesting workaround. Okay, now the documentation mentions two main deployment types, managed Flex Gateway and self-managed Flex Gateway. What's the difference?
It really boils down to who manages the underlying infrastructure that Flex Gateway runs on. Managed Flex Gateway is fully hosted by MuleSoft on their Cloud Hub 2.0 platform.
So MuleSoft handles everything, the servers, the updates.
Yep, they manage the hosting, high availability, auto-scaling, patching, updates, all of that. It's designed to be simpler, less operational overhead for you. You interact mostly through the platform UI. In this model, the runtime units are called gateway instances.
Sounds like the easy button, maybe. What's the
Well,
alternative? Self-managed.
Self-managed Flex Gateway is, as the name suggests, a runtime that you deploy and maintain yourself.
So on my own servers.
Yeah.
Or in my cloud account.
Exactly. Could be in AWS, Azure, GCP, your own data center, even locally on a developer machine. You get more control over the environment, but you also take on the responsibility for managing that infrastructure, the OS, networking, scaling, patching.
Right. More control, more responsibility.
Precisely. And this model gives you different installation options: Docker, Kubernetes, Linux service, RPM package. And here, the runtime units are called replicas.
Yeah, managed for less overhead, self-managed for more control and flexibility, but you own the infrastructure upkeep.
Right.
Now, within self-managed, I saw connected mode and local mode mentioned. What's that distinction?
Right. So in connected mode, your self-managed Flex Gateway maintains a persistent connection back to the MuleSoft control plane.
Okay.
This is what enables that centralized management we talked about, using API Manager and Runtime Manager to configure things, apply policies, see metrics, all through the Anypoint UI. This is generally the preferred mode if you want that UI-driven management experience.
So it's running on your infrastructure, but it's still phoning home to the Anypoint platform for instructions and reporting. What about local mode then? Sounds disconnected.
It mostly is. In local mode, the self-managed Flex Gateway operates largely disconnected from the control plane. It really only connects initially for registration and then maybe periodically to report usage metrics for billing.
How do you configure it? How do you apply policies?
Ah, that's the key difference. In local mode, all the configuration and policy definitions are done using declarative YAML files that are stored locally right alongside the gateway runtime.
YAML files for everything.
Okay.
That sounds very infrastructure as code friendly.
Exactly. Local mode is particularly well suited for integrating into CI/CD pipelines. Because your configs are just code these YAML files, you can version control them, automate deployments, manage them as part of your standard dev lifecycle.
Got it. So connected mode, UI management, full platform integration, local mode, YAML driven, better for CI/CD automation, less reliance on the control plane day to day. Makes sense. Okay, let's just gears to the deployment patterns. The docs outline 4 main models, right?
Yes, 4 main ones: Standalone, Ingress, Egress, and Sidecar. And it's worth noting these apply whether you're using connected or local mode, although obviously in local mode diagrams you wouldn't see the Anypoint Platform piece.
Right. Let's start with standalone. What's the scenario for that one?
Standalone is typically used inside your organization's network. Think of it as managing internal traffic, like communication between different microservices or internal systems.
So protecting internal API flow.
Exactly. It sits within your network perimeter and secures traffic for one or maybe multiple internal integration flows, like maybe between your order service and inventory service, keeping that traffic protected internally.
Okay. Internal traffic management. What about ingress? That sounds like dealing with the outside world.
It is. And Ingress Deployment is all about managing external traffic that's entering your internal network. Flex Gateway acts as the gatekeeper at the edge.
Protecting back-end services from external requests.
Precisely. Protecting one or more integration flows from requests coming from the internet or external partners. You often see it deployed behind a load balancer, too, to distribute that incoming traffic. This is actually the most common deployment model people use.
The most common, okay.
And interestingly, a single Flex Gateway can actually be configured to handle both ingress and egress traffic at the same time.
Ah, okay. So egress must be the opposite then. Traffic going out.
You got it. Egress deployment manages internal traffic that's trying to leave your network. For instance, maybe your internal application needs to call a third-party API, like a payment gateway or a weather service.
So Flex Gateway controls and secures those outbound calls.
Exactly. And just like with Ingress, it can also be configured to handle both directions if needed.
Right. So standalone, internal, ingress, inbound, egress, outbound. What's the last one? Sidecar. Well, that sounds different.
It is a bit different. In a sidecar deployment, the Flex Gateway instance is deployed very closely alongside the specific application or service it's protecting.
Like one gateway per service.
Potentially, yes. Each Flex Gateway replica in this model might only protect the APIs of its specific associated service. So if you have, say, 20 microservices, you might end up with 20 Flex Gateway replicas running as sidecars.
Wow, okay. That sounds like it could get complex.
It can, especially with many services, but it aligns very closely with concepts like service mesh, where each service has its own dedicated proxy. It offers very granular control. You could also choose to group a few related APIs under a single sidecar gateway, too.
Interesting. So very fine-grained control,
Yeah.
but potentially more moving parts.
Yeah. Okay.
And how do you tell these gateways where to send the traffic, the routing configuration?
Yeah, how you configure routing depends a bit on the mode and where you're running it. In connected mode, you typically define the routes right in the Anypoint Platform UI, the control plane,
Okay, point and click.
pretty much. But if you're in local mode, especially running on Kubernetes, you'd use things like Kubernetes custom resource definitions or CRDs.
Ah, the Kubernetes way.
Exactly, or even standard Kubernetes ingress resources to define how traffic should be routed.
Okay, that gives us a really good handle on the deployment options. Now, I'm keen to get into that practical demo you mentioned from Vikas Sharma. Setting it up as a Linux service. What was the main goal there?
So Vikas's main goal was really practical. Show the step-by-step process of installing Flex Gateway as a Linux service, specifically on AWS EC2 instances.
Right.
And then crucially, show how to set up multiple replicas of that service for high availability, and then tackle that common challenge of enforcing rate limiting consistently across those replicas using Redis.
Yeah, that shared rate limiting is a big one. Okay, so how did he start? What were the first steps?
He kicked things off by launching 2 EC2 instances using Amazon Linux 2. And he specifically noted that Amazon Linux 2 is one of the supported OS options for Flex Gateway.
Okay, standard Linux instances. And he chose connected mode for the demo.
He did, yeah. He mentioned preferring connected mode because, well, you get all the management advantages through the Anypoint Platform UI, deploying policies, monitoring, etc., which is often easier for users.
Makes sense for a demo, and for many real-world cases too. So how did he actually install it on the first EC2 instance?
He went into Runtime Manager on the Anypoint Platform, navigated to the Flex Gateways section, clicked Add Gateway, and chose the Linux service option.
And the platform just gives you the command.
Yep. It generated the specific installation command needed. He just copied that command and ran it on his first EC2 instance using sudo.
Straightforward enough.
Yeah.
What about registering it? Getting it connected back to the platform?
That involved running the register command, which again the platform provided during that add gateway flow. This required a few pieces of information.
Like what?
He needed to authenticate using a connected app, so he had to supply the client ID and secret for that app. He also needed the environment ID from API Manager, his sandbox environment in this case,
Okay.
and then set the connected flag to true, provide his MuleSoft organization ID, and specify an output directory for the registration files following the documentation's guidance.
Sounds like a few details to get right. Any hiccups there?
He did hit a small snag, actually. When he first tried to run the register command, he got a permission denied error.
Ah, Linux permissions. Classic.
Exactly. He quickly figured it out and used sudo to grant the necessary write permissions to the directory he'd specified for the registration output, a common thing to run into.
Good to see the troubleshooting step.
Yeah.
So after successful registration, what was the status?
Right after registration finished, the new Flex Gateway showed up in Runtime Manager, but it was initially in a disconnected state, showing 0 replicas online.
Okay. Registered but not running yet.
Correct. So the next step was to actually start the Flex Gateway service on the EC2 instance using the provided system command. Once he did that, the status in Runtime Manager quickly updated to connected, showing 1 active replica.
Right, replica 1 is up. How did he add the second one on the other EC2 instance? Did he have to repeat that whole registration dance?
Not quite. He did need to install the Flex Gateway software on the second instance using the same installation command as before.
Okay, install is needed.
But for registration, he took a shortcut. Instead of generating new registration details from the UI, he just securely copied the registration.yaml file.
The one created on the first instance.
Exactly. He copied that file from the first EC2 instance over to the second one. He used FileZilla for the transfer, but you could use STP or something similar. He did have to chmod the target directory on the second instance first to allow the copy.
That's clever. So the second instance uses the identity of the first registration.
Essentially, yes. It joins the same Flex Gateway registration group. After copying that registration.yaml file over, he just started the Flex Gateway service on the second instance. It read the config file, connected back to Anypoint, and boom, the runtime manager showed 2 connected replicas for that gateway.
Nice. Very efficient way to scale out.
Okay, 2 replicas running. Now the important part, deploying an actual API to be managed by this gateway. How did he do that?
He went over to API Manager in the Anypoint Platform, clicked Add New API, and when it asked for the runtime, he selected the Flex Gateway he just set up with the 2 replicas.
Makes sense. He chose to create a new HTTP API definition, gave it a name something like Live Twit API Demo, configured it to listen on port 80, set a base path of API, and then for the backend implementation URL, he used a simple public test service, http.httpbin.org.
Okay, a basic proxy setup, then save and deploy.
Yep, save and deploy.
And did it work? Could he hit the API through the Flex Gateway?
He did. He tested it by sending requests to the public IP addresses of both EC2 instances using port 80 and that AP path. In both cases, he got the expected response back from httpbin.org, confirming the gateway was successfully proxying the requests.
Excellent. Proxying works. What about adding some control? He demonstrated policies, right?
He did. First up was basic authentication. He went into the API configuration in API Manager, added the basic auth policy, and just configured a simple username and password right there in the UI.
Okay. And the effect?
When he tried accessing the API again without credentials, he immediately got a 401 unauthorized error, as expected. Providing the correct username and password in the request then allowed access again. Standard stuff, but shows the policy enforcement working.
Good. What was the other policy? Rate limiting.
Yes, rate limiting. He added that policy next, configuring it to allow 5 requests per minute. He also checked the box to expose the rate limit headers in the response, which is useful for clients.
Okay, 5 requests per minute. What happened when he tested that across the 2 replicas?
Initially, when he tested using Postman, he saw the rate limit headers correctly, but he noticed he could actually make 10 requests within a minute, 5 to the first replica's IP and 5 to the second replica's IP before getting rate limited.
Ah, right, because each replica was tracking the limit independently. They weren't sharing the count.
Exactly, which is often not what you want. You usually want a single global rate limit applied across all instances serving that API.
So this is where Redis comes in to provide that shared state.
Precisely. To fix this and enforce a unified limit, he configured shared storage using Redis. This involved a couple of steps on both EC2 instances.
Okay, what did he have to do on each machine?
First, on both instances, he needed to create a specific directory. MuleSoft Flex Gateway Custom. He needed sudo for that.
Right.
Inside that custom directory, again on both instances, he created a YAML file. He called it shared-storage.yaml, but the name could probably be different.
And what goes in that YAML file?
This file tells Flex Gateway how to connect to the Redis instance. It has a standard structure, EPA version, kind, configuration, metadata, and then the important part under spec shared storage, then Redis, and under that, the Redis address, the public endpoint, username, and password.
Okay, so connection details for Redis, where did he get those?
He mentioned he'd set up a free tier Redis cloud account beforehand and just grabbed the public endpoint URL, the default username, and the password from there.
Got it. So he populated that shared-storage.yaml file with these Redis details on both EC2 instances.
Yes, using sudo again to edit the file in the protected directory. Once that file was in place on both replicas, he restarted the Flex Gateway services. Or, well, he implied they'd pick up the change, maybe automatically, or on the next policy update.
Okay. And the moment of truth, did testing the rate limit again show different behavior?
It did. He went back to Postman, hit the API endpoint repeatedly, and this time the 5 requests per minute limit was strictly enforced across both instances. After the 5th request, regardless of which replica served it, subsequent requests were blocked until the minute rolled over. The shared Redis cache was doing its job.
Perfect. That really shows the power of using shared storage for consistent policy enforcement in a distributed setup.
Did he mention any other Flex Gateway features?
Briefly, yeah. He flashed screens or mentioned things like configuring TLS contexts, for using your own certificates for HTTPS, setting up forward proxies for controlling outbound traffic, using the API Manager API for automation, and integrating with CI/CD tools like Jenkins. Lots more capabilities there. Good to know it has that depth. And what was the final piece of the demo? Something about a load balancer.
Yes, the final step was putting an AWS application load balancer, ALB, in front of the two EC2 instances.
For high availability and traffic distribution, right?
Exactly. He walked through creating two AWS target groups, assigning each EC2 instance to its own target group. Then he created the ALB, configured it to listen on port 80, and set up routing rules to distribute traffic evenly across both target groups.
And the final test? Accessing the API via the load balancer's address.
Yep. He got the DNS name of the newly created ALB, set requests to it, using the same AP path, and showed that he could successfully access the API, including passing the basic authentication. It confirmed the load balancing was working and traffic was flowing through the Flex Gateway replicas behind it.
That's a really solid end-to-end demonstration. From install to HA to policies with shared state, all fronted by a load balancer. Super practical.
Yeah, it covered a lot of common ground.
Okay, so having seen it in action and discussed the concepts, let's try and summarize. What are the big advantages, the main benefits of using Flex Gateway?
I think the biggest one, really, is that ability to manage all your APIs, MuleSoft, non-MuleSoft, wherever they live, from that single Anypoint platform.
Unified management.
Exactly. And that means you can extend all the good stuff from Anypoint, like its policy framework, analytics, monitoring, to all those APIs, not just the Mule ones. You get consistent security and governance.
Which probably simplifies operations quite a bit. Less tooling, fewer dashboards to watch.
Definitely. It helps break down those silos you often see where different teams manage different API types with different tools. And we saw how it integrates with CI/CD, which is huge for automation. Plus, the deployment flexibility Ingress, standalone, sidecar, lets you fit it into various architectures.
Those sound like strong positives.
Yeah.
Were there any limitations or downsides mentioned to the sources?
Yeah, a few things came up. In another part of one of the videos, not Vikas's main demo, it was mentioned there's sort of a practical recommendation, maybe around 400 APIs per Flex Gateway instance.
Yeah.
Something to keep in mind for really large scale.
A potential scaling consideration.
And of course, with the self-managed option, the onus is on you, the organization, to manage and secure that underlying infrastructure, the servers, the OS, the patching, scaling. MuleSoft manages the gateway software, but you manage where it runs.
Right, the trade-off for control.
Another limitation noted was around custom policies. Currently, if you want to write your own custom policies to apply via Flex Gateway, they need to be written in the Rust programming language.
Ah, okay. Not Java or something more common in the Mule world. That's specific.
It is, yeah. Something to be aware of if you rely heavily on custom policy development.
The videos also had some Q&A. Any interesting points go up there?
There were a few good ones. Someone asked about availability in, government clouds.
Oh, yeah, GovCloud. Important for some sectors.
The answer was basically that it's available in the standard MuleSoft EU and US control planes, but for specific dedicated government cloud environments, you'd need to check the latest specifics with MuleSoft. They weren't sure offhand.
Fair enough. What else?
Someone asked how it compares to other gateways like Kong or Apogee.
Yeah, common question.
The clarification was that Flex Gateway acts as that management layer for the API lifecycle, and, importantly, it can manage non-Mule APIs without necessarily needing to build a separate proxy application for each one, which you might do traditionally. Functionally, as a gateway performing traffic management and policy enforcement, yes, it's in a similar space to Kong.
Okay. And policy management specifics.
Someone asked how policies are applied. The answer confirmed it's done through API Manager, applied to the specific API instance being managed by Flex Gateway, much like you do with APIs on a traditional Mule runtime gateway.
But with that Rust limitation for custom policies we just mentioned.
Exactly. And finally, there was a question about costs, specifically about vCores.
Right, because Mule runtime deployments often consume vCores.
Yeah. The clarification was that, unlike deploying Mule Access proxies, you don't allocate vCores directly to the API instances being managed by Flex Gateway itself. The cost is really tied to the infrastructure you provide to run the Flex Gateway replicas, the EC2 instances, container resources, load balancers, Redis, etc. Your infrastructure costs depend on your setup.
That's a helpful distinction on the cost model. Okay, so wrapping up, Flex Gateway really seems positioned as a powerful enabler for that universal API management vision.
I think so, yeah. It tackles that complexity of having APIs all over the place, built with different technologies. It provides that unifying layer for management and control.
For me, the key takeaways are definitely that architectural split control plane for management, runtime for execution, the flexibility between managed and self-managed deployments, and connected versus local modes within self-managed.
Catering to different operational needs.
And the huge benefit of applying consistent policies and getting visibility across all your APIs via Anypoint Platform, especially in connected mode.
Yeah.
Plus, just its core ability to handle non-MuleSoft stuff.
Absolutely. And if you want to dig deeper, the MuleSoft documentation is really the place to go for detailed setup guides, all the deployment options, policy configs. It's quite comprehensive.
Yeah, and worth exploring those other features mentioned, like the TLS context configuration, or really mapping out how you'd integrate it into your CI/CD processes.
Which leads us to maybe a final thought for you, the listener, to consider. If you were to adopt this universal API management approach using something like Flex Gateway, how might that fundamentally change how your organization handles its APIs?
Right. What new levels of efficiency or maybe even security and control could you achieve when you stop managing APIs in separate silos and bring them under one roof?
Definitely something to think about.